Welcome to the video on VoskenAI Stage 1, Requirements Specification. This is the first phase in the 8-stage hardware design automation pipeline, focusing on transforming user briefs into formal hardware requirements. Hardware requirements often fail, even with good teams. Requirements are typically written in simple documents without formal coverage checks, leading to silent gaps and untestable requirements. For a moderately complex IP, the manual requirements process takes around 40 engineer hours, with a high risk of 25 to 40% rework later. Informal language creates untestable requirements and leaves crucial coverage gaps. Incomplete requirements have real costs. Missing power requirements, ambiguous interface specs, and unspecified edge cases can lead to expensive respins and schedule slips discovered late in the process. VoskenAI Stage 1 uses a 3-agent pipeline to go from a plain English brief to a verified specification. The output includes formal requirements, acceptance criteria, quantified targets, and a full traceability chain. For a real 32-bit timer IP example, one paragraph of user brief resulted in 35 formal requirements in under 2 hours. The review agent automatically added 2 requirements missing from the original brief. Intent capture is the first critical step. The agent extracts explicit statements, implied meaning, and identifies gaps, such as unspecified prescaler encoding or interrupt polarity, flagging unconfirmed assumptions early. The process involves 3 agents. The creator writes the full specification. The reviewer applies 7 quality checks without modifying the spec. The reviser applies surgical edits, fixing flags and creating new requirements. The review loop runs the spec through the creator, reviewer, and reviser for up to 3 cycles. Most specifications pass after 1 revision. If critical findings remain, the spec is finalized with unresolved items flagged for engineer action. VoskenAI enforces 12 mandatory categories, including functional, interface, performance, power, and error handling. This ensures that commonly skipped requirements, like edge cases and DFT, are always addressed. Every requirement is structured with a unique ID, title, type, priority, and description using the mandatory IEEE shall language. Quantified targets and traceability links back to the source are also recorded. Acceptance criteria are machine-readable test specifications. For example, the programmable prescaler requirement generates 2 simulation tests, automatically defining the method, criterion, metric, operator, and conditions. The register map is generated from plain text, detailing registers like TCSR0, TLR0, TCR0, and TCFG0. This specifies exact bit positions, access types, and reset values, driving register generation in later pipeline stages. VoskenAI automatically generates error handling requirements not found in the original brief. Examples include defining behavior for writing to an undefined AXI address or writing to a read-only register. One critical edge case, REQERR-003, addresses what happens if the load register, TLR0, is 0 when the timer is enabled. This real integration bug is caught as a coverage gap before RTL design even starts. The system also detects and resolves conflicts, such as the clock domain crossing latency conflicting with the interrupt latency budget. Mitigation strategies are automatically suggested, like using a clock-enable model. Traceability is unbroken, linking every design element from the user's initial statement to the final RTL and testbench assertion. This makes impact analysis a simple database query. VoskenAI automatically catches 10 common pitfalls, all of which appeared in the timer IP execution. These include missing units, compound requirements, and failure to specify CDC requirements. The final timer IP specification, Spec TMR001, contains 35 requirements across all 12 mandatory categories. 2 crucial requirements were added by the reviser, ensuring complete coverage. With VoskenAI, the time to specification drops from 1 to 2 weeks to under 2 hours. Engineering effort is reduced significantly, and the risk of rework is dramatically decreased to under 5%. Stage 1 creates the foundation for the entire pipeline. Functional requirements guide system architecture. Acceptance criteria drive test bench generation. The structured format serves as the interface for all 8 stages. VoskenAI Stage 1 takes plain English input and produces formal, fully covered requirements in under 2 hours. It eliminates silent assumptions and provides the essential foundation for the rest of the automated hardware design pipeline.